I have slides for both, one on WebTransport and one on web codecs. Who here is interested in one topic or the other? So WebTransport, raise your hand. Web codecs, raise your hand. Okay, so it's about equal.
Can you also maybe like present to the Hangouts in case like folks ask for more participation? So
Sure.
I don't know if there is anyone. It looks like there isn't, but in case folks show up.
Oh, that's going to do the inception thing.
Probably.
Did that work? I think so. Okay, so given that Victor's not here yet, I think we'll do web codecs first and then roll the dice on Victor showing up. Is that okay with everybody? Although Paul's not here for web codecs, so.
Morning session.
Okay.
I can take over for Victor.
All right, well, let's go with WebTransport then. And if we have to, we can like come back to either one. All right, where's the present? So yesterday at the breakout session, we did a high-level overview of WebTransport, what it is, how it compares to existing things, some examples, and we had some pretty good technical discussions. So I wanted today to try and dive deeper into some of the technical issues that we have on the GitHub repository. Is there anybody that missed the breakout session yesterday and doesn't know what WebTransport is and wants a quick intro? Okay, then I will do a quick
very
intro.
quick one then.
Yes.
Yeah.
All right.
It transports on the web.
I don't know if this is actually what's being presented now, so.
It is. It is.
Okay, good. All right. So it's a generic API for client-server networking that, unlike WebSocket, allows for unreliable and unordered data, as well as reliable and ordered. It's based on QUIC and HTTP3, unlike WebSocket that's based on TLS and HTTP 1.1. There's a lot of demand from games developers for something like UDP on the web. We're hoping this gives the closest thing, but still secure. A lot of people ask for something like this for live streaming, network gaming, and advanced real-time communications. Here's a quick example. The top half is typical MSC stuff. And the bottom half is like making a thing called quick transport. Pass in your server host and port, and then you can say, okay, I want to receive streams, and then I can read stream, pull it out, and stick it in the MSC buffer. So it's kind of like receiving messages from a WebSocket, but slightly different.
Okay.
Similarly, there's support for datagrams, which is closer to UDP semantics, where they're unreliable and out of order, but limited size. So here's an example where we're sending datagrams. This is something game developers have asked for. And in this case, we just take some game state that fits in one UDP packet, and we send it off to the server. Most of this is like the noise of using what are called WG streams, readable streams, writable streams. Most of it's just like, hey, I want to transport, I want to send datagrams, send the datagram every 100 milliseconds or so.
So the retry and correctness semantics are built into the effectively to send datagrams to the API, or it's part of the transfer?
No. So there's no reliability guarantee for datagrams at all. It's up to the application.
UDP semantics.
Built into the API, effectively. There are none.
Yeah.
The fact that there are none is built into the API.
Yes. The fact that there are none is built into the API.
To clarify that, you have integrity protection, and so you know that if datagram arrives, it wasn't corrupted. It is the one that was sent, but if it gets lost, it gets lost.
Okay.
It's still encrypted and it's still congestion controlled. We also have a version called the HTTP3 transport, which is multiplexed with HTTP3 that with a connection you already have to the server, so it doesn't have to make a separate connection on a separate port. Just uses the existing connection or creates one if you don't already have one. So in this case, you just give it a URL and say, okay, I want to connect in that context and then receive data for that. It could be either streams or datagrams. So compared to WebSocket, as I already mentioned, supports unreliable out of order, and it uses these readable and writable streams, which is similar to the new WebSocket stream. It's a kind of improvement on the WebSocket API. It is very similar to the RTC data channel in the sense that you have unreliable and out of order, but it's a pain to do the RTC data channel to a server because it requires ICE and DTLS and SCTP. It requires a lot of round trips to set up. The status is that we have here in the WICG an explainer and a spec. The implementation for client server and Chromium is starting soon. There was a peer-to-peer version that was an origin trial and is now behind a flag. So you can do a peer-to-peer version of this, but it was for an older version of the API that didn't have readable and writable streams. And there's work going on in the IETF to standardize the small amount of protocol work necessary, which is similar to the WebSocket protocol. Okay, so
Thank you.
any quick questions before? Yeah.
Quick questions.
Yeah.
Who else other than you're Google, right?
Yeah.
Who else other than Google's involved or customers?
Sorry, who else at Google's involved?
Other than Google.
Other than Google.
Like Zenwicked is their partner.
So you mean people that are requesting this
Is
to
there
be
anyone
used?
engaged in the
So on the discourse, yeah, there's a discourse page, the proposal there. And there are lots of people that have expressed interest in using it. As far as the standards side of it, most of the engagement has been from Microsoft. But then yesterday there was a good conversation with Mozilla and Apple on it.
Who specifically from Microsoft is engaged? Who specifically from Microsoft?
Bernardo Boba. And we also presented at W3C Games conference a few months ago, and there were many game developers there that expressed interest in using this, mostly for cloud gaming, but for other gaming purposes too. Okay, so I need to close this one, go to that one. I wanted to go through some specific technical issues. This is the list that we have on, I mean, it's not all of the issues on GitHub, but it's the ones that are kind of interesting to discuss. One of them being, this isn't on the list, but it's something worth discussing. We have some specs, and maybe we can wait till Victor gets here, I don't know, we'll see. We have some specs in the ITF that we need to progress, and that probably means making an ITF working group. And so there's some question as to how the interaction should work between the W3C and the ITF. Is there any precedent for the WICG being a part of ITF work or being coordinated with an ITF working group at all, or has that always been?
So there are no yet precedents for a successful graduation from WICG to the ITF. There are a bunch of things, a bunch of RFCs that are currently being incubated in the WICG. So UA client hints and web packaging are ones that come to mind. I don't think that there are any, we haven't heard objections to graduation from.
So to clarify, this wouldn't be a graduation. This would be two separate specs.
Oh, interacting? That.
Well, one IETF draft to define the transport components and one WCC document to define the API.
Right. Kind of like WebSockets did.
That sounds perfectly fine.
But if there are things like client hints that have a precedent, then that makes it a lot easier for everyone on how to smooth those the contact points.
Yeah, I don't like generally. I believe Wendy is the
Yeah,
the
we
liaison,
had a
but
conversation yesterday, and also general agreement was that we should proceed in the manner where they're in parallel, and we kind of agree on like the general needs. But they're still developed independently.
Yeah.
And I think so far there's been agreement that general needs are questions that would impact both protocol and API. Like for instance, the URL field. We decide to add the URL fields, the protocol would have to communicate it somehow. But other than that, there aren't many interesting things from the interaction.
yeah, in general, like defining the transport blocks here and the API here, so like it seems like pretty standard procedure. So
Yeah, as I said, but the requirements like basically have to agree.
Okay. Is there any clarity on whether the parallel work can be ITF working group, WICG here versus?
At least, so from an ITF perspective, the only requirement from the ITF is that they're users of the new standards coming out of the ITF. So as long as there's interest, and from the ITF's perspective, if it's a W3C like working group, community group, they don't know what the difference between those are. So as long as it's like, oh yeah, the W3C wants this, then okay, then there's momentum, let's do this.
Well, it's like ITF is a forum, for clients and service or peers to interoperate. So as long as those parties are present, I think we can facilitate ITF, and similarly, as long as there are developers and browser vendors present in W3C, we can pursue the W3C.
Okay. All right, I'll move on to the next issue then, which is a technical one, not a procedural one. Basically, the WebSocket stream, which is an improvement on the WebSocket API that's happening independently of WebTransport, has defined this WebSocket connection object, which has readable and writable streams of messages, basically. And WebTransport has the datagram transport for sending and receiving datagrams, and it also has readable and writable streams of datagrams, which are kind of the same thing. The difference is that for WebSockets, they're in order, reliable, and of unlimited size, whereas for a datagram transport, they're out of order, unreliable, and of limited size. So the question is it worth converging these so that applications could like deal with one API shape, even though the semantics are different?
I mean, they are like they're at least different, but max datagram size. I mean, that's one of the distinction. It's not even the key distinction, but the key distinction is one of them reliable, another is not. I think we should converge in the fact that one uses property and other uses getter setter. I don't think so message transport is an interesting topic because like if you think about it, that would be on one hand people have suggested to add message-based transport into our taxonomy because we aim to support transports in general. But the thing is, like the currently existing managed transports are WebSocket protocol and HTTP. And even those two are not quite the same transport because the CTP is many multiple message streams which can be independent, and WebSocket protocol is one stream, so it's like not clear that those are worth conversion.
From a developer ergonomics perspective, is there any reason not to converge?
I think the reason is more confusion. It's like it's important for make things sufficiently similar when they are similar, but it's also dangerous to make things similar when they're similar, but they're not actually the same. And like datagrams is one example because messages, reliable messages and unreliable datagrams are two very different level concepts. And like, if we believe there are contexts in which they're used interchangeably, that would be interesting, but I can't really come up with them.
So I don't think they will be used interchangeably necessarily, but if I am a web developer and I'm working with both of them on different projects, I have one project where I want a reliable stream and another one where I want an unreliable stream, I have to keep those two different models in my head and remember which is which.
Well,
And that's just like, I don't know, I never developed with either, but it seems like a mental overhead without any benefits unless, of
possible
course, I'm
that we
missing
should
something.
have readable datagrams and writable datagrams. As a counterpart to readable and writable, I don't want to lose clarifications of those as datagrams. Because as I said, so there's a semantically important distinction. We shouldn't standard unify that part. But
Sure, but the semantics is determined by, like, if you're working with a datagram transport or a WebSocket connection. And generally, so I don't want to have, like, I think it would be good to talk to actual developers
Okay.
who will use those two APIs and get their experiences rather than speculate.
I think in the perspective of W3C provide low-level API for some features, and then if some developer wanna make some more convenient APIs, then there could be role of framework developers. They can provide some of one interfaces, and then that interface has a parameter as a reliable or unreliable, and then if that interface provide parameter for fixing the size as a parameter, or there are no information for the datagram size, then as a default, that is unlimited or something like that.
It's so sure developers could do that. Or in cases where it's inherent that some smoothing over is required, but I wouldn't consider that something that we want to happen. So if we can create an API that doesn't require such, extra layer of sugar on top, I think it would be better. It would be interesting to maybe raise that question on discourse, and from the folks that expressed interest, get their opinions on this. And it's fairly possible that I'm entirely wrong, and the current API shape is the correct one, but yeah.
I think that's a good idea to throw it out there in the discourse and discuss it there.
I think it's a bit confusing to have readable and writable because the quick transport has function created in the stream, it also has readable writable.
Yeah,
That's what make it confusing.
yeah, I think we would have to make it one step, either embed the name datagram in the attribute or like have it one step down in the function. If we had it transport.readable and transport.writable, that'd be really confusing.
Possibly dumb question, but like send datagrams as a function that returns a writable stream. Does it return the same writable stream every time, or does it return a new one each time?
It returns the same one. It should really just be a property.
Okay.
Okay, so I think going to the discourse is probably the right approach. Next slide. Currently, we have this field inside of, so now we're talking about streams, not datagrams. Datagrams are always unreliable. Streams are reliable, but we have this field currently where when you create a send stream, you can specify that you want to disable retransmissions. And this was used to make unreliable streams. And this was before we had datagram support. So you have a stream, it can be of any size, but it doesn't transmit reliably. And now the question is, well, if we have datagrams, so we just take this away and not have two ways of doing unreliable things. The only advantage to this is if you would like something that's larger than one UDP packet, but still be unreliable, this could be useful for that. But you know, it's a questionable value.
Yeah, I'd rather add enough codes to let developers just implement sets themselves.
If you look at like some of like the game networking protocols out there, it's very common to have this kind of like do not retransmit flag. So it seems like it would be convenient for people.
Possible. If we do that, we would have to like do a lot more definition of what that actually means. Like, okay, like the moment you discover that you need to retransmit, what do you do with the string?
Right. Yeah, at the protocol level, you know, quick streams are kind of very flexible and they can do these kind of things, but then
What
our
does it
API
mean
is a
for
little bit
bidirectional strings?
right.
Only in the send direction.
Okay.
Actually, I don't think we even allowed, we didn't even put the parameter on there for bidirectional. I think we just put it there for the unidirectional.
Is there a use case for in order unreliable? Because it seems like this will give.
I don't think that's keeps it in order, but might be missing.
Yeah. This will give you that, but I don't know if that's actually something people need.
I don't know of any protocol that offers that today.
Yeah.
And well, if you have unreliable, then it's pretty trivial to add a counter at the start of it. And
Yeah, and then order.
Yeah, I think the use case I've seen for that in like the game networking libraries is to basically make sure that you don't receive data out of order on the receive side. You know, you don't really care about retransmits, but you want to make sure that like you don't receive old data once you've seen the new data. But that might be a little bit of a different use case from what this API is.
That is different. Because this would be
Here you just have one kind of flow of streams.
right. As soon as you hit loss, you won't get anything after. Because within a stream, you have head of line blocking.
Sure.
Okay. So sounds like Steve is saying keep it for now. And
Well, I think if we keep it, we probably need to specify what it actually means at the protocol level.
Yeah, because I think it currently just has disable retransmissions.
Yeah, there's probably some loopholes there.
Next one, stats. So currently we have these stats. There was some discussion yesterday about stats, and I was looking to see if anyone else had any input on what else we should have. In particular, if there were, this is currently all transport level stats, and we don't have any stream level stats. So if we needed any stream level stats, make that a little bigger.
I think some of the stats that people might want are things related to congestion control. However, I don't think the stats API in particular is the best place to have that. You should have a dedicated API for it.
I agree.
It's like, you know, the estimated bandwidth of the current moment. We have good buffers. No, it's not.
What's it?
Oh, you have packets sent and packets. Oh no, that's
No,
the other
that's
way.
like when your buffer is full, you send the packet.
Has the number of datagrams dropped?
Received. You should be knowing, technically you should know on the send side, but it might be packet.
I guess that would be something like something act.
I suspect when someone actually tries using this in the wild, they'll probably come up with a lot of stats that they want.
Yeah.
So it might be a little hard to speculate right now, I guess. We can definitely look at things like WebRTC because there's a lot of stats there. I think a lot of them we won't need because we're on the beta plan, but
Next is this use case where currently with the WebRTC data channel, you can connect to a server. It is possible, even though you have to speak all the protocols. And the server has a self-signed cert, which is actually something that people like because it can be easier to deploy a server with the self-signed cert. And the RTC Quick Transport, which is the peer-to-peer version of the Quick Transport, currently allows this by having the fingerprint of the server's self-signed certificate passed into the transport when it started, so that it's not tied to the WebPeak yet. So the question is whether we should allow this same functionality, but without the use of ICE, because the only difference really between the RTC Quick Transport and the client-server transport is whether you have to do ICE, the peer-to-peer protocol.
Question, WebSocket, does it allow the same thing or not?
No.
No, because WebSocket actually does things for synthesis. And therefore, security reasons why to use WebSocket is not possible.
Because it makes perfect sense to have it in WebRTC land because that's peer-to-peer and I'll have to turn to my phone. My phone doesn't have what a domain name is. You get what you guys search for. Here, if it's a server, it's
The use case is actually interesting. The use case we considered are ephemeral virtual machines. Like just spin up machine which runs some untrusted code and then you want to connect it. You don't want to provision that has search for it because it's ephemeral and you don't trust it and you are going to shut it down.
And the distinction between a peer in peer-to-peer world and a server in this world is not. It's rather blurry.
Yeah. The main thing we want to ensure is that we do both certificate check and what's it called? The LPN check, and we do not return any way to like check certificates of servers, which speak quick but do not speak with transport.
Right.
Shouldn't secure by default win though? Secure by default, shouldn't that win? Self-signed cert, or not, self-signed cert, but allowing untrusted search, it goes away in the browser that you can do it. Right? You can say trust this top level domain.
Yeah, but that's a
Issue.
different concept. Like the main reason this is innately secure is that most of regular network requests go through a socket pool, and the socket pool has like bad things happen if you have untrusted search. And there are like, whenever we deal with, there are cases in which user can do things like bypass certificate prompt, but those are like very special, let's put it that way. And then like, a lot of complicated things happen when user clicks a prompt, and here it will be much simpler because we're just not going through that code path.
So maybe something like a different class that allows it, like RPC quick transport, which is more geared to the peer-to-peer scenario. We can say something like when the server has an unsigned cert, it's more like peer-to-peer. If we can remove ICE, we can.
Oh, you mean
without ICE.
You have RTC quick transport constructor that takes a post and a port rather than nice transport.
Yeah.
I think I still put it into main transport because like ICE versus no ICE is a bigger distinction than search check versus custom search check.
But from a developer standpoint, it's like a 3-letter difference one way or the other.
Do we?
ICE versus no ICE? No, that's a big difference.
No. I mean,
no.
I mean if we define the constructor that doesn't require ICE in the RTC quick transport, it's like a 3-letter difference. I guess you have to go start.
Do we have a use case for this client server with non-anchored PKI?
Yes.
The one with ephemeral VM.
Okay.
But you're spinning up ephemeral servers, and yet you know how to connect to them because there's some the routing helps.
Well, it's like we spin up VMs for users on demand.
That doesn't sound specific to this transport. Like fetch does, like you could imagine having ephemeral VMs that you might want to do HTTP fetches from.
Yeah,
fetch
but
doesn't
for
provide-
fetch is like difficult because fetch does things like caching.
Okay.
And if you like allow such things with cache, like you would have the jank security problem.
Okay, so that's the reason that this isn't supported.
Yeah,
by
that's the
fetch.
reason this is not supported in fetch. It's like there are hundreds of reasons of this nature. Like you would also like open HTTP connections that can be reused for something else and things like that. But like there is a long list of reasons why this is something we do not generally allow with HTTP connections and connections that behave like HTTP.
Same reasons might come back though and bite you somewhere unpleasant.
Well, I think not bite us in RTC data channel.
I defer to your judgment.
Like that's my thought process.
Just keep it in mind.
I would currently defer that until we have an implementation. Because once we have an implementation, it's clear how much state we do share versus do not share.
Okay, well, I think that's probably enough discussion on that one. We should probably switch to web codecs soon, but this is probably a good last topic to cover, which is right now we pass in a host and a port, but in the WebSocket world, you pass in also a subprotocol, which might be useful for some contexts so that you can have more than one protocol from the same host and port. And if that thing we pass in is also a URL, then maybe it could be used for, did I say CPS? I meant CSP. But it's not trivial to find a place to put this in the protocol. We basically have to use up a stream somewhere, like hardcode stream 1 or something, to send over the subprotocol. And it would require a round trip to do so. And this would add some complexity to the protocol, and meaning more complex implementation and standardization and so forth. So it's not completely free to have something like this.
Not to protocol design on the table, but couldn't you just put this in transport parameters and get them?
No,
just right?
because client transfer parameters are not encrypted.
Yeah.
That was our original plan. One thing I'm still thinking is that like if we put it on the first stream, but do not block sending data, we could effectively work this around. But like we could effectively do that without losing the RTT, because you could send string 0 with the URL and potential as a full origin, because I'm not sure if you've seen, but there's a new issue where we discussed that people won't actually like to see the full origin. Whereas currently we provide ship a web list, but
So you're saying that for cores, we might want to eat a stream anyway, and we might include both
yeah.
the origin and the.
Yeah, so it looks like there are like some cases for this stream. We should definitely like put a boundary on how much we're willing to put in it. We should not put too much, because as we start doing that, people might want, I don't know, to send the full HTTP header from cookies. And that's something we do not want to do. But so we should agree like that this will be used for like URL, nothing else. But I am afraid like adding a certain place. So
But wouldn't this create a separate connection though, if you're calling the constructor twice?
No, you wouldn't.
That's what I would expect.
Oh, sorry. Yes, if you called the constructor twice, you would get 2 connections.
So why does it matter? If you call the first constructor twice, you wouldn't get 2 connections?
you would get 2 connections, but like you have no idea which of them is which.
Isn't it what you're negotiating with the server off band? Like why do I need to tell the server the sub protocol?
You likely aren't doing any off-band negotiation with the quick transport.
So why wouldn't I be using a stream for protocol 1 and a stream for protocol 2?
So I think whatever we're deciding here, where we send a sub-protocol over stream, an application could do that, where basically they just do the first version, and then they use one stream to send over the sub-protocol. So in a sense, we could just say, okay, JavaScript does this. But if we want to make it slightly easier and more standardized so that there's one way that everyone does it.
I think maybe the use case needs to be more fleshed out in order to, at least for me to give a.
No, it's a very easy use case. It's like you want to suppose you have server A that uses WebTransport, and you have server B that uses WebTransport. And you want them to be able to live effectively on the same host port.
They're on the same host and port. Okay, so that's how you distinguish between who you're connecting to?
Yeah, that's how you distinguish between server A and server B. Think about it like as a situation, like this allows you to do things like build load balancers. And then you have a load balancer, and then you have free server A's and free server B's, and the load balancer would just proxy to the necessary one.
And if how it's done today is like maybe like what do you call the URL parameter or something?
Yeah, for HTTP it's done by URL, and for WebSockets you can also do it by URL or by some protocol, but I think people usually still do it by URL. Yeah, I mean, we had the thing even come up when we were talking about testing this, because for tests, you kind of want the server which does a predefined thing, but you want to alternate between different predefined behaviors.
So maybe you can do it similar, and like the URI, which might be something like quick / might have a protocol first or something. You might be able to get away without adding this star to your.
But however it goes in as the API, it still needs somewhere to be sent to the server.
Well, if it's communicated on the host, I guess. I mean, those are the implementation details.
No, the host doesn't get communicated over to the server.
What is the data format for the sub protocol? Is that a stream?
Oh, that's a good question. That's other question. Is it because one possibility is like you just make them a fake byte string, but there's like, and the other possibility is you replace entire constructor with just a URL, and then the protocol is the path component.
Oh, right, go ahead.
Oh no,
I didn't mean to interrupt either. I was wondering, you said that the host isn't communicated, but isn't, like, you use TLS, don't you? Like, doesn't it get sent by SNI?
oh, the host gets communicated. It's about the which saying of the host.
Okay.
If the host has like which server like binary, for example.
Okay.
Well, for like it's equivalent of like allowing multiple things with logically different on the same server, kind of like URLs allow you to serve different resources.
All right. Well, we should probably switch over to web codecs.
No residency on that.
Yeah, I think
If we think through the load balancer case, for which I can think of multiple products in Azure at Microsoft that have that, I suspect this is a use case that will, it feels to me that for cloud hosters, I guess the other way that's solved is by using host or IP and virtualizing the IP away, which is.
Yeah, which is much more of operational hassle.
Right, okay.
But like what if, how strongly people are afraid or opposed to URLs?
They're sort of already deployed for sockets and they're not brutal, like you mentioned. Are there known problems that you're trying to improve with this design, or?
It's about the network. It's about the actual protocol and how cheap the communication can be, right?
Well, yeah, I mean, protocol complexity is a reason, but as I said, we already kind of have reasons why we might want to add this term back.
Well, it sounds like we can do that from.
Yeah.
Okay.
I agree. So just as an FYI, we went through all but two of the issues. The other two were congestion control and stream prioritization. Congestion control has a really great issue. If you're interested, it has lots of details. Good discussion going on there. And stream prioritization is so hard
agree
that
with this description.
All right.
Yeah, I think like the general thing with streams is kind of similar to the retransmission problem where Quick as a protocol supports many different things, but there's kind of like this level on top, which is like, the controller that figures out what to put in each packet. And because the API is at that kind of higher level, we need to probably have some ways to control that.
So perhaps point of order before we start into the next topic. We have neglected to take notes.
Yes.
Sadly.
Oh,
But we can fix that. So if you guys want to jump into IRC on channel WICG. And then we ought to select the scribe for the next section as well.
For what it's worth, we are recording,
Yeah,
so yeah.
I did take notes on some of the inputs and decisions, but not in IRC.
Yeah.
So it would be better to have somebody
Yeah,
scribing
I'll do the
IRC.
scribe. How about it, Rick?
I mean, I would volunteer, but I don't know anyone's name, so I would have a lot of question marks in front of everyone, so.
The scribe generally gets to interrupt the conversation as people identify themselves.
Sure, it's just inconvenient if it's someone who doesn't know anyone.
And everyone else likes to.
Sure.
Do it.
Sure.
Yes.
Because I'd be in the same boat. Asking the same thing.
All right.
Thank you. And your name is?
My name is Jeremy. We're on with Google.
Thank you.
All right, so same question as last time. Does anybody want the quick intro that wasn't there yesterday at the breakout session?
Yes.
Okay. So Web Codex is about giving a low-level API for encoding and decoding. And basically a long time ago, whenever they wrote the stream spec, they thought about the potential of having a video decoder where you pass in encoded bytes and you get out decoded video frames. And that's what we're doing. They called it, well, they were defining transform streams, and what we are designing is based on transform streams. The only difference is we're also doing encoding.
And audio.
Hmm?
And audio.
And audio, sorry. We're doing audio and video encoding, decoding, not just video decoding. This is useful for live streaming, faster than real-time encoding, real-time communication, audio and video tools, game assets. These are all the use cases people have expressed interest in doing using Web Codex. So in the middle of that diagram is a video encoder. What goes in is image data, along with a timestamp and some settings. What comes out is an encoded bitstream, or a chunk of an encoded bitstream, a uint 8 array, not containerized, just the codec, not MP4, not WebM, but H.264 or VP8 or Opus, and then some metadata like if it's a keyframe or not. And to get the image data to pass into the video encoder, you have to typically convert from a media stream track, which requires something to do that conversion. And so we've defined a track reader to convert from a track and a track writer to go to a track. And that chunk might be useful for other contexts, like there was a breakout session about injectable codecs yesterday. So it's not strictly part of Web Codex in the sense that it's only useful for Web Codex. It could be a separate thing. It's more like a dependency we had to roll into Web Codex because it doesn't already exist. So here's an example where the application has some source of encoded audio and video, which are readable streams, and some place where it wants to render the decoded audio and video, like a video element. In order to do the conversion, you would use track writers, which can take the output of the decoder and convert it into a track, which then can be put in a media stream, which can be put onto a video element. So this is all kind of conversion stuff here. And the meat of it is that you would construct audio and video decoders with specific codecs, and then you would take the source of the audio or video, which is probably coming from a network of some sort, maybe WebTransport, and then you would pipe it through the decoders and then pipe those into the writers, which then pipe them to the tracks, which then goes to the video element. So this is the key part here. You construct the transform stream and pipe through it. If you wanted to encode, so this is an example of here transcoding, which is something people have been interested in. You would first decode and then encode. So the decoder you would set up and then pipe through, but in this case you would pipe through into the encoder, which you would set up with probably a different codec if you're doing transcoding. And then there are settings. This is a short version of settings. I just couldn't fit the whole word on the slide. And there are lots of settings defined. This is just one specifying bitrate. The application would be in charge of figuring out how to, for example, decontainerize or parse a container in a file, and then recontainerize or serialize into a container in order to save to a file or upload or download or whatever. But the web codecs would do the encode and decode. So if you compare this to media recorder, it's capable of doing faster than real-time encoding, and it doesn't do containerization, but it does provide more control over the encode, which media recorder is pretty limited. If you compare it to media source extensions, again, it's not containerized. It can do faster than real-time decoding, and it's lower level. And an interesting difference when comparing media source extensions is that the buffering is done by the application, not by the API. So deciding how much you're going to buffer before decoding is up to the application. So for those doing live streaming, this is really important because they want to have very tight control over the buffering. So if you compare it to WebRTC, again, it's more low level. And the difference here is instead of lacking containerization in the sense of being low level, with WebRTC, it's lacking network transport because WebRTC combines both network transport, which is kind of a containerization. RTP can be arguably viewed as a container. And with web codecs, you can choose what you want your transport to be. It could be the RTC data channel. It could be WebTransport. It could be WebSocket. And again, the buffering is done by the application, not by the browser in the case of WebRTC. All of this can be done right now in WebAssembly, but it's not as fast and power efficient. So the idea here is basically do what WebAssembly is capable of, but faster and more power efficient. Some people are already doing audio and video encode and decode with WebAssembly, but this would allow them to do it more efficiently and have access to hardware encoders and decoders. However, if people want to continue using WebAssembly for custom codecs, maybe some fancy machine learning thing, the part that's defining web codecs around track reading and writing, and also the frames that are in the readable and writable streams would be usable by WASM. And it would make it easier rather than having to go through Canvas, for example, to access the video. So it's an issue coming up about image encode and decode, so you can get into more detail about that. I already covered how containers out of scope and how part of the work of web codecs would help injectable codecs also. So right now we have a proposal on an explainer. We don't have a spec, but we do have some web IDL that's kind of like, you know, a spec without all the text describing what it really means. And here we are in the WICG, and we can discuss technical issues. An implementation will be started in Chrome soon. So any questions before we jump into technical details?
Travis is first in the queue.
Yeah, thank you. I couldn't remember if there was a way to enumerate the supported codecs. You don't have it in your design, but maybe you don't need it because there's already another way of doing it.
Yeah, that's
And is that the same set of codecs?
that's the first issue on the capabilities.
That came to mind.
Okay,
Yeah.
so yeah, and my question is the second issue, so maybe we should just do the issues.
So basically, we want to use media capabilities. We don't want to do our own thing. We don't want I mean, we already have WebRTC capabilities and media capabilities, which hopefully can be unified. We don't want to have a third one. We want to use the existing media capabilities. But there are some specific needs that we would need to have added to capabilities. For example, expressing the difference between a low latency encoder that doesn't have B-frames versus one that does. If it does support B-frames, what the delay is. And then there are a lot of people that want to choose whether it's a hardware or software encoder, not because they think hardware encoder is great, but because they actually want to blacklist it because some hardware encoders are bonkers. And then for low-level things like SVC, there's no support in there right now for SVC inside of Media Recorder or MSE, but we would want to have something in there in web codecs, but there won't be anything right now for media capabilities, and SVC capabilities can get really complicated. And so there's all these extra stuff that we'd like to have in there, and we run into the problem of fingerprinting service, where it's like the more stuff we tell the application, the more issue there is. So that's kind of where we're at. We're like, we want media capabilities to expand to include what we need, but it's hard. Any thoughts on that?
You approached on that?
Yes.
Okay. And they're like, go away.
No,
Are they
they're like,
fully
yes,
happy
we
now?
want to, yes.
Okay. agree with the general.
Yoav is next in the queue.
Yeah, you mentioned, yes,
Okay.
image encoding and decoding. I do suspect that this will be, an ask, if not already.
Yeah.
And it could definitely be interesting. What's the current status, actually?
So there was a lengthy discussion, and I even made a pull request that I accidentally submitted, so it was in the web IDL for a while.
Okay.
And then I brought it back out because it was kind of a mistake. But the more we dug into the use cases that people were asking for, it became unclear whether it was worth having anything there versus WASM, or just having a one-frame video. So we currently consider it out of scope. But yesterday you had that long discussion about image versus video tag, and it occurred to me that if we had something where you could just take the output of a decoder and stick it into an image element, then maybe it would allow application developers to do the same kind of thing with that. I mean, they
So
sort of already
I
can.
think I think the image versus video discussion is very different, because if application developers are involved, they can just have a muted video instead of the image element. In all cases, there are not a background image, and in cases where it is a background image, you can't really do this. So I think that's a separate. I don't think this tackles the use case that people want when they want to shove videos into image elements. I think that you're probably mostly correct when, yeah, people can do things with one-frame video. At least in most image formats today, there can be a future case where you'd have an image format that is video inspired but is not one-to-one identical, and those can and I guess from an API shape, how does it change things? Or why does it matter from your perspective if it's a one-frame video or an image format?
Well, one interesting case would be like GIFs. Somebody said that they wanted to be able to encode GIFs. So if we supported animated GIFs.
As an encoding output?
Yes. So would we call that a video? It gets blurry because right now, as I mentioned, there's no containerization. It's just the bit stream, but a GIF,
yeah.
I mean, is there such thing as a containerized GIF? So that's where it gets a little bit blurry between images, which always have containerization effectively, right?
Yeah.
Versus video, where it's nice to have just the bit stream without the container.
Okay. Okay.
I think the broad summary was that it seems like this is a lot of scope creep, and also that you can already do image encoding and decoding with current APIs. Maybe not things like GIFs, but
yeah, I would be curious to hear the use case for the use case for GIF and why that makes good sense to generate more animated GIFs.
70% of internet traffic is memes. 70% of internet traffic is
Those can be
sure,
better
but
formats.
they should be encoded in a format that's not awful. Okay,
If I can drill into your answer about there being an existing way to do the image decoding, can you elaborate on that?
you can use an image and write it to a canvas, I believe, right?
Okay.
I'm actually not an expert on image encoding and decoding. I just heard this secondhand. So.
And one of the use cases that's come up with just HTML images in general is you want to be able to bring the payload down in the server and then keep it undecoded and then like decode and render sometimes. And then when the page rolls out of view, you want to like recapture that memory, but it can sometimes take a lot of memory to decode the data. But it'll sort of manage that at a fine grained level. I was just wondering, it doesn't seem like that use case has been considered here.
I think we recently shipped something for that. Didn't we? Isn't there like a, I think Josh Bell did some work on
The
it.
decode API? Or
Yeah,
whatever.
so, yeah.
I don't think that quite, it might be shipped in. I don't recall it specifically addressing that particular concern.
I remember it's actually, I could have sworn there was a CDS talk on this, that was exactly image.decode.
Yeah.
Shipped in Chrome 64. Make sure.
Which is a force the decoding of the image now, I think is what it.
How is that on this?
I have maybe a different question on, perhaps I just don't quite grok the scope of this, but is there a way to provide user-defined codec through this API?
That was what I was discussing earlier about injectable codecs. So you can always make your own codec in WASM. The question is,
How do you make it fast and efficient?
well, yes, there's how do you make it efficient? That's where like SIMD extensions come into play. But then there's also how do you get things in and out of it efficiently? And that's where the track writer, track reader, and the readable streams and writable streams of frames comes into play. So a part of what we've defined in web codecs would be useful for use cases like that. And that's one thing we discussed yesterday at a breakout session was how can this allow for injectable codecs into the WebRTC API?
Okay. Are those things done in thread with everything else or somehow off thread through like a workload or something?
It should be possible to do off thread in a workload.
Okay.
Yeah, I think the question of like injecting codecs, I think comes more into like other APIs. You know, how would you inject it into MSC? How would you inject it into WebRTC or an image element or something? Whereas web codecs is kind of more about exposing the platform codecs. I think the things we want to keep in mind is we definitely want to make sure you can write a JavaScript or a WASM codec that you can use in the same way as a web codec. It's a transferable stream.
Well, you would want to be able to have a library that says here's a custom codec, right? It registers it with the system.
So the registering it with the system is the part where it's kind of more of the, it's more relevant for the APIs you'd embed the codecs in rather than web codecs. Like for example, I think someone brought up that capabilities is an area where you might want to expose this as a capability. But if we use media capabilities, and that's a media capabilities question, not a web codecs question.
But you run the risk of like having two different code paths because you can't use the web codecs API when you're using a custom codec, right? Your application might want to choose dynamically between these codecs.
Sorry, name?
Amit.
No, I
Google.
think what we're saying is part of web codecs is defining a common surface area for what a codec looks like. And so if
Yes.
WASM implemented the same surface area, then places that use web codecs could also use custom codecs and vice versa.
You're saying the difference would only be object construction and you'll be passing it down, it'll be fine.
Yeah.
I can buy that.
Yeah, and also by building on the streams of the structure, you get like transferable streams. You could instantiate a codec on a worker and then use it on a main thread or something.
Very fussy for me right now, but I'm
Okay.
willing to take it on faith.
All right, so who's going to guess what the third topic is? So far, I've got the first and second. I don't even remember. Let's find out. Ah, yes. SPS and PPS. So basically, some codecs require extra stuff. And so we have to,
SPS and PPS?
Any H264 experts in the room?
Before answering that.
I read the spec and I don't remember.
There are things that you need though.
Are those things which would be provided by container normally?
Yes, they would usually be in the container. Funny enough, in H264, there's actually two ways of doing this. You can either embed it in the bitstream or give it as side data. Usually for video files, they'll give it as side data.
Yeah, so basically an app is going to parse the container, because that's out of scope for web codecs, and then it needs to pass in this into the decoder, for example, somewhere. And the question is where. So our best shot at this so far is to put it in the settings that you pass into the decoder. Now, it might not actually look like this. It might be a little more flexible. Huh? But you know, this is just the general idea of like goes into the constructor.
Is this the same kind of out-of-band data that's in JPEGs, for example, that isn't exposed in other platforms? How the exit data and other metadata?
So I think that would be more like kind of container data, whereas these are things that the codec actually needs.
Right. This isn't nice to know metadata. This is like you can't decode without it.
Okay. I'd be jealous if this would allow you to get that other stuff. You could get it for images.
Right.
I have a related question on like construction. If I understood correctly, you wanted these settings to be part of the IDL, or is it just a freehand dictionary?
No, so that's why I was saying we would probably have it slightly different. So like in the WebRTC world, we have basically an array of key value pairs, and that's probably what this would be.
Yeah.
This was
fine.
easier to read.
Excellent. That's how.
Yeah, I think
it
a lot
should be.
of the settings will be codec specific.
Yeah, and
Yeah, we don't want to bake SPS and PPS into the web IDL.
or even baking something like Proto's one of H264 parameters or that would be, it wouldn't allow you to extend it with new codecs in
Right.
the future.
Yeah, this is why the
Yeah.
WebRTC option is a
Okay,
vector of key value pairs.
excellent. Thanks for
Yeah,
that.
I think
answer.
figuring out how to write web IDL for this, I don't think that's a pressing challenge.
Right, I was just trying to focus on
Probably a
the
challenge.
pass it in the constructor thing here. Okay,
I think the big question around here, which maybe if we can find some more codec experts, is kind of do these things, is it fine to just kind of specify them as static things when you construct the decoder, or do you also need ways to like inject changes in the stuff in the like as you go that could influence kind of like whether it shows up in the chunk or whether it's good enough to be in the constructor. I mean, certainly this would be easier. So if it's good enough, then that'd be great.
no H264 experts in the room? Okay.
But in general, how are these different than other parameters like the target bit rate or things like that?
Well, so there's a difference between kind of like things that are necessary for understanding the bit stream, and then things that are kind of like hints for the encoder, for example.
Right, but once you're saying there's a distinction between the two, and
The explainer
things-
explains this as well.
This parameter is for decoder, not for encoder.
Yeah, what I'm saying is once you're saying already that there's a distinction between them, then if you do need to change any of these dynamic, they would just be part of the other APIs. You don't have to tackle that problem.
Perhaps, like kind of as the explainer is written right now, things like SPS, PPS wouldn't fall in. Like,
Well,
wouldn't be a
those don't fall in
valid
the category.
setting.
But we're saying, are there any that do fall into that category? I think that's what you're asking.
Oh, the question is, are there any like parameters which are necessary for understanding the bit stream that that are not known when you first start decoding? Like we need to go to consult some codec experts then.
Yeah. All right, any other comments before the next one? So this one's kind of fun. Does everyone know what a B-frame is?
Beta frame.
So basically, in a video codec, there are dependencies between frames, and a B-frame is when you're dependent on a frame from the future. So when you go to decode it, you have to decode it out of order. And so the question is, if we're going to deal with these, how do we do that from a decoder's API, from the API of the decoder? So initially,
Buffering, I'm assuming would be the naive approach, but yeah.
so my initial shot at this was to just require the JavaScript to do it, where basically the JavaScript hands it to the decoder in decode order, and then if it wants to present them in a different order, then it buffers them after decode, and then
Okay.
it handles that. But we've been told that there are hardware decoders that do the reordering internally, and it's better to use it that way.
Let's make sure they're at least consistent.
Yeah, I mean, the decoder needs to hold on to the frame anyway, because if you have to decode B frames, you need to reference the key frame that it refers to. So it feels like most decoders would already do this reordering for you, or could do it efficiently.
You mean even software decoders?
But even the software decoders would be able to do it.
Sure. Well, so the question is whether we make the API such that the encoders can do this perhaps more efficiently. And so that's what we've done so far, is we've added a timestamp to the information that goes into the decoder so the decoder can do the internal buffering. But if you were opting in for a real-time or low latency encoder or decoder that didn't have B frames, then you would, like, this timestamp would be useless or unimportant.
Yeah, I think requiring timestamps is not too onerous, even if you don't really need them. You can just increment them by one if you want to.
Right.
This seems a lot like surrogate pairs in double byte and beyond character sets, where it's really kind of useless to get half of it. You know what I mean? And in almost all cases, you just want to get the full character. So, like in the HTML encoder and decoder, when you need to stop parsing, you never stop halfway through a double byte character. You always either end right before it or right after it or something like that. My question is, does anyone need to know, like, is the B frame, is that an implementation detail that can be sort of handled before you expose it out to the API?
So the way it would look in this case, you wouldn't get like partial images. You would just get them out of order, basically. So you specify the keyframe in the future, and then you specify the frames that come before it. So I think the question is whether or not you would get that frame from the future immediately when you submit it, or if it would wait for all the B frames to go by first before outputting it. So the B frames are like kind of the delta frames that refer to things in the future.
So yeah, your options are, you see a B frame, you know you can't, you know that what follows is going to be out of order. So do you just stop and wait and accumulate, or do you release it and let pass the bug downstream to let them know about B frames and reorder?
Yeah, I think that's the question.
Yeah.
Like similar to before, I would actually ask the people that are supposed to use the API as to, like, is there an actual use case to get the frames out of order? Which, like, sounds weird, but maybe. And then, like, what's their preference in terms of, do they want the API to magically handle that for them, or would that be too magical because they won't have access to something?
Yeah, so that's a good idea to go on the discourse. I'm almost certain I know what they will say.
Okay.
All right.
It's like, do you want to do extra work, or would you like us to do that for you? That's kind of what we're asking.
Sure, if that's the case, then the answer is obvious. The question, like, would it be more efficient in some way if it's done in JavaScript? It doesn't seem like it would. So, yeah.
Cool. We can move on then.
Okay.
Also, when you say timestamp, please specify which timestamp it is.
It's the presentation timestamp.
I'm just asking, so like, because this is already confusing spot.
Yeah, yeah. Okay. Should we call it quits or get into the really mind-blowing one?
We don't have, I believe, anything else on the agenda for today, so.
No.
You're welcome to push on.
Okay. So, SVC
You might want to define SVC.
is scalable video coding. Is that it? Or
Yes,
coding? I think it's coding.
coding.
So basically, it's like progressive images, but for video, where you have different layers that depend on each other. And it can be very useful for, or it is very useful in the real-time communication world for video conferencing. But it could be useful for other contexts. I'm surprised that it hasn't made its way into the world of real-time or live video streaming and that sort of thing. And I think it will in the future because it's very useful.
You can even use it for offline playback too. You don't want to have like, 5 different resolutions of your video.
True. So basically, you can have one bit stream where if you have only a portion of the bit stream, you can just decode a lower resolution or lower quality version. If you get the rest of the bit stream, you get the whole resolution or whole.
How does that work in terms of video length? Like, is that per a period of time? So for every X frames, you can.
It gets really complicated.
Okay.
Yeah, I mean.
I think the simplest way to think about it is each frame you could have like three chunks. One will give you, if you just decode one, you get the 480p.
Okay, so for each frame
add-
is progressively decoded.
Yeah.
So
that's
if
like
you want to drop some of you have
can't
to
read it.
drop a portion of each frame as you stream them.
I don't think you can drop an arbitrary portion.
There we go.
You have to drop
Yeah,
the higher
there's-
frequency.
Yeah, of course, but yeah.
Yeah, they
Okay.
can get very complicated like that. So
Yeah,
Yeah,
so
I think that-
maybe there is no, like, if everyone here are fully aware of what that is, and no need to dive into that.
I think the simple case is like this, where you have a bigger version and a smaller version. The bigger
Yeah.
one is dependent on the smaller one.
Yes.
And then for each time slice, you have both.
Okay, so each frame
big and a
is a progressive.
Yes.
Yes, okay.
But it, can really get bonkers. So,
Yeah, okay. Super
in
interesting.
some ways, you could see SVC as being somewhat similar to like JPEG progressive.
Yeah.
coding. It doesn't really. It's a little different, but
Sure.
it's kind of the same
Yeah.
idea.
but from a encoder API standpoint, the interesting thing is that you put in one frame and you get out n frames for the same timestamp potentially. In the case we were just showing,
And
it's like
chunks of bytes.
yes. So you get different things for the same timestamp, and B, there are dependencies between them that are kind of like the time dependencies in normal video frames, but in this case, it's on at the same time. So that's one thing that's different that impacts the API. The other is that when you're decoding, you will put in different frames for the same timestamp. So something might happen where you get the lower quality one across the network first, you decode that, and then maybe you choose to render it, and then you get the higher quality one, you decode that. It's dependent on the first one, but now you get another video frame, but for the same timestamp, and you might choose to render that. So there's the idea of one frame in, one frame out kind of falls apart
Goes out the window, yeah.
when you start talking about SVC. So we've tried to integrate that into the API, but expressing how you want it set up, like those different diagrams can get very complex, and also expressing what is possible through media capabilities can get complex.
Yeah, and you also potentially, is there a preference thing? Like, I'm a low power device, so send me the only partial layers, but not the full. But maybe that's something that, and this is JavaScript API, so it's like the client and server can communicate that in an application.
So what a common use case for real-time communication is the client will tell the server, you know, send me the highest resolution of this particular video you can, and then the server's adapting to network conditions, and moving down or up or dropping frames in between, because it interacts with tempo scalability also.
But the device can say this is the maximum
Yes.
amount of quality that I can handle.
Yeah.
Yeah, that's in signaling.
That's
In RTC, it's in signaling. And here, application.
Yeah, it's in signaling, but maybe like as part of the media capabilities that maybe you also want to include that.
Yes, you'd want to know if you're capable of decoding
that
SVC
kind of quality.
and what the maximum things you can do. Like you might have a limit on how many layers you can do or something. So it's not just for video. Audio actually has a funny thing also. So Opus FEC, the way it goes over the network is that a particular packet can contain both the current times high quality audio and a previous times low quality audio, so that if you missed a previous packet, you can use a lower quality version of it from this packet. Does that make sense? So there's redundancy in being sent over the network. So when you receive a chunk of Opus bitstream, when you go to decode it, you can actually decode either a high quality current frame or a low quality past frame. So you probably want a way to express that.
I think for the FEC, Opus FEC case, it might just be able to figure it out kind of automatically, right? Based on the gaps in the timestamps. If you're feeding it, you know, you have a gap, you can feed it some more data and it has low quality, it probably should just give you that. You can probably assume you're not going to get the high quality at that point.
That's a good point. I mean, we could treat it like SVC basically, where if you get the earlier one first and then the higher quality one later, you get at a second audio frame.
Yeah, I guess
of the same time.
Yeah, and then on the encode side, you just need a way to turn on the FEC, and I think you should be okay.
Yeah, turning it on or off is easy. It's really specifying which one you want at the decode.
Yeah, so I think maybe the summary here is SVC very hard. Opus FEC might be tractable, might be not be as challenging.
Well, simple SVC is not so bad, but it can get really crazy.
Yeah, I do think we have to figure out. I think that one of the big things for like SVC decode is, you know, you have multiple layers that make up like one frame, and you know, if you kind of expect to get all the layers, you don't really want to get the image until you provide them all. But if you're going to drop like the highest layer, the highest quality layer, you don't want to have to wait until like the next frame to get the thing out. So you might need a way to like kind of flush out the SVC or whatever. I don't know.
So what is the actual, like, what's the question here? The question is, should the API support it out the bat? Should the API be able to cope with adding support for that in the future, or something else?
I think the question is how can we shape the API now so that these kinds of use cases can be done in the future, even if we don't include or implement all of the complexity of SVC right now. We don't want to paint ourselves into a corner, but we also don't want to have to implement like all this stuff to.
Yeah, I think the big kind of design consideration here is, you know, you can't assume frame in, frame out, you know, chunk in, frame out, whatever.
Yeah.
Okay.
But at the same time, a future application that will use those fancy coding modes will be aware of it, and they can, like, they will need to know that, you know, multiple frames may come out. Or,
yes.
Yeah.
This one's more for Paul. So we probably shouldn't do it without him. But a high-level summary is that when we convert from readable streams to tracks, and then it goes to be played out, for audio, you're going to just want to give audio to the operating system every time slice that it needs it, so and avoid gaps. But for video, it's a little more complicated where to keep the video smooth, you might want to specify when the video gets rendered, as opposed to having a video frame get rendered at every VSync and then the JavaScript be expected to like keep a little buffer full at every VSync, if that makes sense. So if you just take the video frames out of the decoder as fast as they're coming and then go to render them, it might not be smooth.
Sometimes it's going to have to skip frames to keep the video smooth. Is that what you're serving, or
It'll either be a buffer overrun or underrun.
Well,
From the perspective of the rendering.
so imagine that the VSync is 60 hertz and you're decoding at 24 FPS.
Yep.
Like, how do you decide which frame goes in which VSync if you're just dumping it into the buffer and the algorithm is, you know, pull the next thing out of the buffer, you might get like 2 frames really fast and then none for a while and 2 frames really fast. So instead you'd like it to be smoothly done. And so then the question is like, how do we express that? If we put JavaScript in complete control, then it's kind of prone to the sorts of things that happen with JavaScript where it pauses. So it might be better to put a timestamp on it and let.
At the same time, that's a concern with people who do like WebGL and stuff. It's, you know, being able to run JavaScript with every frame. So
that's a good point.
Maybe it's not that intractable.
So this is just something we haven't figured out yet, basically, that eventually need to figure out. And we might not have a good solution until, or a good answer until we actually go to try and implement some of this. But Paul has a lot of better ideas than I do about this. And
it's just super interesting now that you asked. So is all that's expected to be done off the render thread in general?
yes.
And so it can then be to an off-thread media stream track. You know, it's going to be pumped in on a worker.
Yeah.
Okay.
And maybe that makes it okay to have a very low level thing where the JavaScript is controlling which frames go out of which VSync. But
It's still going to be more efficient for the JavaScript not to have to wake up on all the right frames and to just pass the data along as part of the document. But you know, I'm not actually an expert, so.
and for some use cases where the latency isn't as important, it might be much more clear to have more buffering and smoothness, and maybe for WebRTC thing or RTC things, then they're like, you know, wanting more control. So we just don't know yet. This is kind of where we're at.
Anything else?
No, that's the last slide.
All right.
That's all I got.
Thank you, Peter.
Yeah, thank you, Peter.
Thank you for coming.
And Jeremy, right, for scribing. Thank you very much.
All right. Cool.
All right.
Okay.
Chairs,
And-
what's next? Anything that should be brought up? Sort of open floor time. Just